Today I am solving the JEE Advanced 2019 Physics question paper. Here the section is 1 and the question is a spherical insulating cell of radius r. A spherical insulating cell of radius r is uniformly distributed charge such that the potential at the surface is V0, and this is the point C, suppose, and this is the point A, suppose. So this is also the R, this is also radius R, and if I consider in another point B in the center of this radius, this is the r by 2. This portion is r by 2. So here we can write the charge distributed in this spherical cell dq equals to q by 4 pi r square into dA. This is the q into alpha, where alpha equals to dA by 4 pi r square. dA is the small change in area. This dA is the small change in area, and the charge is dq is the small change in charge, and this is the total charge. This is the total charge divided by 4 pi r square. So here the surface potential V0 at surface is equals to kq by r. This k is the 1 by 4 pi epsilon 0. The cell is this. This is C. The radius of this cell is r. Radius of this is r. And if I consider any point B in the middle, this is r by 2. This is r by 2. And if this increases into outside, if the point is A, this radius is also r. So the potential at C, V at C, is equals to the potential at the surface kq by r minus k alpha q divided by r. So here alpha equals to, we know, this dA by 4 pi r square is the alpha. So this equals to V0 into 1 minus alpha. Then the potential at the point B, for the point B, the potential at the surface minus the potential for the at the radius r by 2. At the radius r by 2, this equals to V0 into 1 minus 2 alpha. If I take the ratio of these two, Vc and Bv, if I take this ratio, Vc divided by Vb is equals to 1 minus alpha by 1 minus 2 alpha is equals to this. This is the correct option. If I calculate the electric field at point A, then EA is equals to electric field at point A. This is the point A. This and for the point A the radius is this r and this r. This is 2r. R plus r is 2r. 2r whole square minus k alpha q r square. This is for the cell. The total field up to point A, this is the total field up to point A minus the field across this cell. So this is the electric field at the point A. This equals to kq by 4r square, kq by 4r square minus alpha v0 by r. Here this term alpha v0 by r is reduces. So electric field is reduces by this term, reduces by this term. And if I calculate the electric field at the point C, then it is at the point C, this is k alpha q divided by radius is r square. R, so this is r square. This equals to alpha v0 by r. So this is increased. So this is increased by alpha v0 by r. So this is the electric field at the point C. So here the ratio of potential at the center of the cell and the point at 1 by 2r from center towards the hole will be 1 minus alpha divided by 1 minus 2 alpha. This is the correct option. And the magnitude of electric field at the center of the cell, this is reduced by alpha b0 by 2r. This is not the correct option. And the magnitude of electric field at a point located on a line passing through the hole, the cell center, on a distance 2r from the center of the spherical cell will reduced by alpha v by 2r. This is also the incorrect option, and the first also, and the correct option is the third option. So that's all for today.